Hey math kids, today we're going to talk about variance and standard deviation, and we're in chapter 12, section J. And so I'm going to write down a few of the formulas that we're going to use today. So, got to get a color you can actually see. Okay, so we have sigma squared equals this, and then I equals 1, xi minus mu squared all over n. And then we also have this, which is the same thing, but under a square root. Okay. Now, just to be clear, this square root is over everything. Okay. So these are two ways that we can express a similar idea. The top one, we say it's the population variance of a data set, where mu is the mean and n is the number of data values. Okay. Now we just have two examples, and we're going to look at this on both of them. And so we're given some data. This is example 12 in your book. So we're given 3, 12, 8, 15, and 7. And it says find the population variance and standard deviation for these data sets. So the pieces that we need to find, let's get this color. We need to find mu first. So mu, once again, is just the mean. And so we're going to add these up. We're going to say 3 plus 12 plus 8 plus 15 plus 7, and divide by the number of data points. So 1, 2, 3, 4, 5. And if we were, let's just do that on a calculator. So 3 plus 12 plus 8 plus 15 plus 7. So we get 45 over 5, which is going to be 9. Now, that's our mu. So in either of these equations, wherever we see mu, we're going to use 9. Okay, so let's find the variance first. So we'll do sigma squared equals. Now, what we're going to do is I'm only going to focus on the top of this first. So we're going to take each data point and then subtract the mean and then square it. So I'm not going to actually do that part yet. So we're just going to say 3 minus 9 squared. And then this symbol means to add it together. So I'm going to put a plus sign. And then we get 12 minus 9 squared. Then 8 minus 9 squared. 15 minus 9 squared. And then 7 minus 9 squared. Okay. Now, we just want to simplify all of that. So we're going to say 3 minus 9, which we get negative 6. 12 minus 9, we get 3, negative 1, positive 6, and then negative 2. We square each of those. Negative 6 would be 36. 3 and 3 times 3 would be 9. Negative 1 and negative 1 would be 1. 6 and 6, 36. Negative 2 would be 4. So that's going to be 40, 50, 60, 70, 80, 86. So the entire top part of this is going to be 86. we just add all those together. And then we have to divide by the number of data points, which was 1, 2, 3, 4, 5. So if we go to our calculator and we do 86 divided by 5, got 17.2. And so that is our variance. So sigma squared is 17.2. Okay. Now, the only difference with our variance and our standard deviation is we just need to take this and square root both sides. So if we just want to find our standard deviation, we just take 17.2 and take the square root of it. So 17.2 raised to the 0.5 is one way we could do it, or we could say or we could do second 17.2, and we'll get the same answer. So it's 4.15 if we round and go out to 3 significant figures. Okay. Yeah, that's pretty much it if we're doing it by hand. And now if you want to go here, I'm going to show you how to do it on a calculator. So what we want to do is we want to, let's see, where's the stats function on this? I'm not seeing it for some reason. Oh, it's right here, stat. Okay, so we want to calculate a one variable stat, but before we do that, we have to edit a table. And so we go into here. Let me start that over. So we hit the stat button, then we go to edit. So we can just hit 1 or enter because we're highlighted there. Then we just enter our data points. So they're written in blue right there. So 3, enter, 12, 8, 15, and 7. Okay, we can go quit, and that was stored in L1. Hopefully you noticed that. We go back to stat. This time we go over to calc. Then we want to do a one variable stat, and then we just have to tell it which list to look at. And so it was in L1, so I go second, L1, hit enter, and it gives me all this data. So X bar is our mean, which was 9 that we calculated. N was 5. And then when we go up here, so we had 17.2 as our variance. Let's see. I guess it doesn't give us variance, but it gave us our standard deviation right here. Yeah. So if we were to do this, we would do it kind of backwards from how we did it. So this is our standard deviation, the sigma x. So 4.15 if we round, which is the same thing we got right here. And then we'd have to square that. We'd have to say 4.15 squared to get our sigma squared. And when we do that, alright, we get 4.15 squared, and we ended up with 17.2, which is the same thing we got right there.